Hi, and welcome to our talk about data in games and our use of it in narrative sound design. My name's Dominic Vega. I'm a lead sound designer at Avalanche Studios Group, and leading our talk today is Zan Williams. But first, about our studio. Avalanche Studios Group is a game development studio spread between 4 locations in Stockholm, Malmo, New York City, and Liverpool. We're most known for making vast open-world games, best known for their bombastic action and over-the-top worlds. We have a number of projects of varying sizes in development at any one time, and an in-house audio team of sound designers, technical sound designers, and audio programmers who service and make these games sound spectacular. Zan, who's one of our most senior technical and creative sound designers, has played a huge role in defining our methodology around rich audio implementation and is here to lead today's talk.
Hi, I'm Zan Williams. I currently work at Avalanche Studios. I've been here since 2012. Prior to that, I was working at Eurocom Entertainment Software, and these are a bunch of titles that I've worked on. And I'd also like to introduce the hidden third member of this talk, Nicholas Verhagen, our principal sound programmer. You'll see me using a bunch of different visual scripting languages, but all of the code that underpins those was written basically by one person. That was Nicholas. Over the course of several projects, he and I have had a kind of back and forth, wherein with using the technology, I would identify things that I was finding difficult or would have ideas. I would workshop them with him, and we evolved a lot of this stuff kind of chaotically, but in a direction that made it specifically useful for these kinds of tasks. That process was always a lot of fun, and I think because of the hard work he's put into this, it's worth giving him a shout out here.
So, a little bit more about the talk specifics. Triggering individual sounds in games is accomplished using pretty standardized game dev and middleware tools, and those methods are really similar across many different types of games. But something that Zan and I both don't see talked about a lot is how sounds are choreographed to form soundtracks in somewhat chaotic open-world sandbox games. Now, at Avalanche Studios, we've spent a number of years learning some of the right and certainly some of the wrong ways for us to take information and data from the game and use it to define meaningful moments. We're going to look at some of our past projects where using a sound designer's idea of narrative context and the right game data helped us to orchestrate better soundtracks. So we want this talk to be for anyone who is looking at approaching music design for the first time, and we want to show how it looks for us in practice at a relatively large scale in AAA open world games.
We'd also like to present music design and music scripting to anyone who hasn't approached this before. So the way I see it, this talk should be equally relevant to experienced sound designers that haven't had cause to think about this kind of stuff before, as well as programmers who might understand how to program systems but don't necessarily know what the demands of music design would be. We're hoping to be able to talk to you like we would talk to programmers we work with in a studio, both gameplay programmers and audio programmers. And we're hoping to show some of the methods we use to turn data into narrative state.
So now why this talk and these presenters? Well, we wanted to talk about context awareness and design in soundtracks for games overall, but one of the most easily understood ways games and sound interact and portray any kind of context to the player is through music. Now, depending on projects, Avalanche often loves to interweave this same audio context from music into other things like the mix or the sound design. This, however, presents a really compelling challenge for our audio coders and technical sound designers who have to own the task of sourcing and deriving data to form that context. Now, a sound designer like myself can take the sort of tracklaying phase of game assets quite literally. I see something in the game, I want to add sound to it, and I need to work out how. As well as these sounds, I'll likely want to add some intelligence and intentionality into them. So perhaps an ambient sound of an icy combat arena should change its content makeup as the time of day modulates from night to day. The same goes for music, right? It's a sound content event. I want to inject some awareness into it, so I want to grab a bit of basic data from our game. When an enemy comes around the corner, I want to play some combat music based on, say, line of sight. A basic problem that we face in any kind of sort of combat or threat scripting scenario is going to be whether we want to warn the player using music that an enemy is around the corner or not. And here comes in the issue of defining context, because it matters what our intention as designers is for the player experience.
This mutant monstrosity is one of Second Extinction's raptors, and somewhere under the scripting for the raptor we have this node, which we use to play sounds, to manage data, and do other things like set up raycasting rules for occlusion. This is a category of node that we can put on characters, but we also might want to put these on locations or all sorts of other props in the game. And you can think of this as being analogous to a wise game object, which will have game syncs and sounds childed to it. And in the debug for the Raptor, you can see a set of constant values that we call tags, and you can also see some filtered data. So historically, we've always had this variable awareness state AI. The AI scripting, usually in behavior trees, will write to this value. So every character kind of has a sense of whether it's in combat. So again, I've hacked the game a little bit to have the presence of the dinosaurs affect the different music states in a very simple way. At the moment, the presence of a raptor is tension, and presence of a raptor with the combat state on it is combat. So if I spawn a raptor, you see tension music triggers. If I alert it, he goes into combat. Combat music triggers. So that's all fine and well, that makes sense to the player. What happens when my experience as the player doesn't match up with what's going on the screen? So the combat state as it's currently triggering on the dinosaurs is actually the global combat state being pushed down to all dinos. This is quite a normal way of coding up a global combat state, and it's definitely the right thing to do if you're thinking of the combat state as being something that's defined by like an omniscient game director. So usually when I work with games teams, their first implementation of a combat state will work like this. So what you see the music system responding to is the global combat state, and that will give you results like this. So now if I run to this arena, a dinosaur will spawn. So there he is, spawning behind the box. But the only way I know about this right now is because of that debug text. There is a little bit of like dinosaur roaring in the background, but sometimes they can be quiet. And yet we have tension music on. So now already as a player I'm kind of like forewarned about the presence of a dinosaur that I shouldn't really know about. If I do something to alert it, all hell breaks loose. That, when he comes around the corner, is really when I'd want the combat music to kick off. A big surprise stinger as suddenly he jumps out of nowhere. Now here's a little bit of a better way of doing it. It's a very simple case still, but it works around the problem I just showed you. So I've changed the tension state to only look at raptors we've detected. I'll explain a little bit more about how the detection works in a bit. And I've set combat to trigger when any enemies are in combat and when they've been detected by the player. Now if I run my scenario again, I see the two raptors spawn, and you'll notice that no combat music plays. Ignoring the spawning sound, we'll pretend like we don't know the dinosaurs are here. If I spawn a raptor off in the distance, I will get tension music playing. He doesn't notice I'm here yet. And once more without triggering tension first. Now they're still silent, maybe pretend we didn't hear the roar. As soon as they come on screen, it's high combat music. So in our journey from data to narrative, let's begin with data. And the first thing to consider is what types of data we're working with. I like to think of these as being in two distinct categories. One would be stuff that we gather, and the other will be stuff that we derive. So by stuff we gather, I mean anything that exists in game code or gameplay scripting that we want to work with over in audio scripting. And the approach to working with this is go find it. Here's an example where I'll work with the game's time of day parameter. This is Apex's game editing tool, the wittily and never ironically titled Just Edit. Here's the game window. This is a node tree editing pane, and here is a property pane. At the top I have a location open, and a location is a resource we use to load in scripting. These manila folders are something that we just use for sorting out chunks of scripting, and they're stripped at compile time. The blue icons are entity files. Entities are small templates of scripting that we can instance inside of location files. The higher level objects we call game objects, and they can be extended with components which will give the game object extra behavior. I've set up some debug scripts to run when the game boots, which will mess around with the mix for the sake of these demos. I'm mostly only saying this here so that I don't freak out my colleague Dominic when he listens to these videos. But we're not really here to listen to stuff. We're here to look at debug text. This tool is called ARC, which stands for Apex Remote Console. Apex has a sort of vintage console, and this little website allows me to send console commands directly to the game. Here I've hacked the game's music system so that the time of day is triggering combat music at night and tension music during the daytime. I can use these buttons to simulate sending time of day values directly from ARC, so this isn't coming from game code. You'll notice that the console command has a set structure. It's the same structure that's used in the console, as well as game scripting, and in game code. So if I provoke the game to change time of day, we'll have that value pushed to us. And so this is a very valuable way of being able to work, a very simple single point of access to push data to us that we can use in animation scripting, behavior trees, graph scripts, and a host of other access points. This is important to us and the project when everyone's thinking about balancing requests, especially requests that demand programmer time. So if you're requesting a task of the coder team, perhaps to create data for you or to have data pushed to you, and the resulting work is a 3-day task, that'll never get prioritized relative to a crash bug. It'll sit on a priority list very, very low, and it'll probably stay there. There'll always be new higher priority things coming in. So it's important to us to try and reduce the amount of time it takes to serve us with the stuff we need. Much more likely that they'll be able to squeeze in a 30-minute task as well as fixing the crash bug. So having a single line of code to push data to us means that we're requesting the smallest amount of time per task possible. We don't want to request any expensive tasks. If it's an expensive task, especially if it's only in the service of audio, then we'll attempt to do it ourselves. So then on to stuff we derive. Why would we want to do this? Surely a single source of truth is best, right? Well, I would agree. It's better to have most of your concepts described globally at a game level that anyone else can access when they need to. However, while it's true to say you want a single source of truth, there can be many different perspectives on that truth, which is what we saw happening earlier in the foreshadowing example. There was a difference between when the game knew about the presence of the dinosaurs and their attempts to attack you versus when the player would become aware of it. So what was important was the player's sense of combat rather than the omniscient game director's sense of the combat state. There was the global game perspective and then the perspective that was important for audio. Which brings us to the state bit, which you can also see as stuff we derive continued. So first of all, I think it's worthwhile looking at what I will often kind of incorrectly call the state machine. This node is what we refer to as our state machine. I've cheated and pre-configured this with a few variables that we'll be using in the demo, but I've yet to add any states to it. If I paste these in now, you'll see they appear in debug. And I just want to point out that although I'll be cutting a lot as I fluff my lines, I'm not actually closing just edit or recompiling any code. Any changes I make in the tree view scripting will appear here in debug because they're being created in the runtime. As you might expect, a state has events, and the events can trigger on state enter, during the state, or as the state exits. And as is usual with state machines, you can use external commands to set the state. Now, I would tend that having to be set externally means the state itself is quite lazy. And we can make our states do a little bit more work because we can give them their own conditions for activation. This collection of nodes acts as a logical statement. To get something up and running, I'm going to make exploration always be true. Earlier, I promised to talk a little bit about how we're doing the detection of the enemies. We have another node here that we use as a kind of global blackboard for sound data. We can take data from the game into the sound system and push it where it's needed. Notice that the variables aren't just a name and a value. We also record other information. such as the previous value or the max value. As well as storing data we get sent to us, this blackboard can derive its own data. There's a type of node here called an automated variable, which we use to query the data on the dinosaurs that you saw us working with earlier. The same logical conditions that states use to evaluate their own truth are used to build the query that we use to interrogate the state of different dinosaurs. So far we've been working with raptors exclusively. If I wanted to start working with T-Rexes as well, I could create, or in this case cheat and enable, a brand new automated variable. I would need to set it up to point specifically at something unique to the T-Rex, such as a tag. I'll run a similar example to earlier, except this time raptors trigger low combat. Now if I can spawn a T-Rex while they're harassing me, I get into high combat. Once I've killed the T-Rex, I go to this state pre-combat tension because there is only one raptor left. He's not enough of a threat to warrant combat music, but we want to keep something playing. I'm going to add one more state. This is post-combat tension, which is different to pre-combat tension in that it cares about whether or not you're coming from exploration or somehow from pre-combat tension. It specifically won't be true if you come from either of those two states. Other than that, it has exactly the same logical conditions as pre-combat tension. So it might be possible coming out of combat for both of these to be true. It's perfectly valid for two states inside a single FSM to be true at the same time. We resolve those by having the user be able to assign a final priority value. And that priority value means that if any two states are true at the same time, the user has a way of saying which one they would prefer to be active. There is a difference between states that are true and a single finite state within one state machine that is active. Now if I run the same example again, kill the Rex, and one of the dinosaurs. Now I have post-combat tension. So hopefully you could follow a lot of what was going on there. It can be very difficult to show scripting in our engine because the Apex engine is bespoke. But there are a few things that I was hoping to convey. One was, although that was quite a simple, pretty spurious example, it was something that I was able to set up extremely quickly without needing to compile. And that's because there's an enormous amount of power hidden in the nodes that I'm using. So thank God for Nicholas, basically. Another important point is that the states are self-evaluating and they select themselves as being the active state rather than being set externally. You can end up with multiple states being true at once, but the relative priorities of the states determines which ultimately is the one single state per state machine that's active. You could also see that variables had a current, previous, and max value. There are a few other pieces of data they store as well that weren't displayed in this piece of debug. Having variables be more than just a single value is another way to derive extra data. And that gives us better logic, which you could see in the post-combat tension example. Here's a simple version written out in plain text, so you don't have to worry about reading our scripting. So the logic can help us arrange consecutive state, and it helps us contextualize data. So far you've seen an example from Second Extinction where I'm using a single state machine, and the only slightly unusual bit here is the way they self-evaluate. But what kind of scripting is this when we start using it at a larger scale? And that's a pretty good question. What has happened at Avalanche over the course of a number of projects is we've slowly built and grown a thing that we're using without really thinking too much about what formal computer science concepts were that underpin it. So I'm sort of in a weird position today of trying to explain to a room full of people who can probably identify what's going on better than I can what I think this is. But it's a question that I've been asked a couple of times, and it's interesting to go and try and work out what it is we've been doing on these projects. So I suspect it's some kind of decision tree. We often end up using multiple state machines in concert to derive a single result. which we could do by having a lot of complicated logic inside of a single state machine, but it's easier to break that logic up into multiple state machines. If we assume it's a type of decision tree, and by we I mean me, then what type of decision tree is it? Well, thankfully, after 5 minutes of Googling, I came across this really useful paper by Stanford University, which describes the difference between hierarchical finite state machines and behavior trees. Let's look at what they say. For anyone who doesn't know, a behavior tree is something that's quite commonly used to script character behavior in games. So if a dude decides to attack you, it's probably because of a leaf node that's been reached on a behavior tree. And the way these things work is they start with a root node, they'll go down to branching nodes, evaluate some stuff, and then eventually come to a single leaf node. And that leaf node executes something on, in this case, a character. Now, although at the end of the tree you have different leaf nodes, they often push out to a single source. You often see examples of a behavior tree controlling a single finite state machine. Individual subtrees can be saved out as different files and reinstanced and reused later. So these are praised for their maintainability, the scalability, and the reusability of their nodes. What they're not so good for, and in my experience I've had this when trying to get data from behavior trees that we run in our games, is the ability to work with transitions and the ability to know when you're leaving one leaf node and going to another. If the behavior tree isn't connected to a finite state machine, it can be very difficult to get that information. And an important feature to think about here is the fact that behavior trees evaluate from a single root node all the way down the tree to a final leaf node. And that's not necessarily something that's bad or that we can improve upon, it's simply that we're doing something a little bit different. We tend to use individual state machines for different kinds of gameplay, for example, and they're going to end up fighting over what piece of music to play. So when we're resolving all of these different state machines, we have a single finite state machine which helps sort out what to do with all of the different decisions being made by the nodes above them in the hierarchy. Those state machines themselves are made up of individual states which have their own logical conditions. So how does execution work in our model? We don't start from a single root node and evaluate down. We begin execution if a single condition changes, which causes the state to reevaluate, which causes the whole state machine to reevaluate, which will eventually cause the sorting state machine at the bottom to evaluate. We end up with a single state, which allows us to pick a single piece of music. So we don't have a single root. I have a bit of a weird metaphor that I like to use. I like to think of the data acting as a bunch of different tributaries, which are all feeding a single river that runs out to the ocean. I guess the ocean in this case is the music. Another interesting concept we have here is inheritance. The scripting in JustEdit allows me to template pieces of logic, template states, template whole state machines that I can override and extend. And that gives us the feature of behavioral inheritance. Here you can see an example from Rage, where a specific activity state machine is inheriting from a generic gunfight state machine. So when we have lots of state machines working together in a hierarchy, we end up with what I think is a hierarchical finite state machine. And our ability to template different parts of the hierarchical FSM means that we have a version that's much more maintainable, much more scalable, and we can more easily reuse components of it. But we also have transitions baked in, because at the bottom of it we're working with a single finite state machine, and actually we have finite state machines all the way along the hierarchy, which means we can work with transitions at any point. There are some limitations. What I showed you in Second Extinction was tree-based node scripting and some on-screen debug. And we found that ultimately, although the scripting for the logic is quite visual, the graph of all of the state machines working together isn't displayed at all. So overall, it's not particularly visual. It's not very readable and it's not very learnable. Basically, the graph of it exists as a picture in my head, and it's quite hard for other people to access that. You might have noticed that I breezed past the concept of transitions there rather quickly, and transitions are super important when it comes to music scripting. Today I want to talk more about how everything is structured and less about the specifics of music triggering. But if that's of interest to you, we can talk a little bit more about how transitions work in this system in the Q&A section.
Now, to zoom out of the in-depth data aspect of these implementation systems. From a sound designer's perspective, and to the sound designers in the room, how does state and the context and what we would call kind of the automation relate to us and our workflow? Some of the words that we kind of set up internally that work kind of across the post-production realm into sound design that find their way into our tool set is tracklaying and automation. Like the above, where you see this is a trailer setup of how we're designing and mixing sounds with automation lanes and different assets swimming in and out of each other in a linear format. In games, we don't use time in the same way that we do with linear content like in film and television. And so we use analogies for things like tracklaying and DAW. We would be referring to implementation or triggering of sounds in our engine using a lot of the techniques Zan is outlining. Automation, where we're mixing things and moving them, maybe moving parameters on a DSP, we would kind of refer as state. And that includes culling, mixing, and modulation.
So in a DAW, sequences of regions and automation curves are a kind of narrative context for sounds, or they help you mix sounds. They help you manipulate sounds. And what's important is that you're able to change that manipulation over time. The context of the moment before is important to the moment afterwards. And that's kind of what's happening in the post-combat tension. It's important that you're able to do something different post-combat than you were pre-combat. It's narrative over time. But in games, and particularly in open world sandbox games, we don't have access to linear time. So it's very difficult for us to be able to define a beginning, a middle, and an end to any story that we want to have affect the soundtrack. Even more complicated when you consider that we tend to have multiple beginnings, multiple middles, and multiple ends for any given story. Instead, what we can get relatively easily is a bunch of disparate, simultaneous but very chaotically arranged state. And what we're looking for is a way of being able to make this state consecutive in time in a way that's meaningful. So if you want to build narrative, you need to find a way to link these states consecutively. And that'll give you the beginning, the middle, and the end. So if you can solve consecutive states, then you can start to build a narrative on top of this chaotic, dynamic sandbox gameplay. In other words, we've been able to build a kind of narrative backbone for the game that we can hang all of these music decisions, sound design, and mixing decisions from. States become the tracks and regions that we're now able to put automation on. So those are some of the building blocks we work with. We gather global game data and use that to help us derive data that's more useful for us. We can query the state of different things in the world and use that information along with global game data in these state machine nodes. Stuff we gather, stuff we derive.
So let's take a look at a large-scale example that's in relatively recent Avalanche history. Rage 2, developed by Avalanche, was this high-octane, fast-paced first-person shooter with intense car combat mechanics and a massive, massive world. With a tagline like "Insanity Rules," anyone like me in a creative seat would be drooling, and while I didn't work on this game personally, I can only imagine the opportunity for Zan to add endless depth and dynamism in and out of ridiculous over-the-top scenarios in a post-apocalyptic world.
It's also quite an ironic tagline. Rage 2 music design, I guess. If you're given the task of solving music design for a giant open-world action sandbox game like Rage 2, you might, hypothetically, at the beginning of the project, feel a little bit panicked. That's fine. As far as I know, that's totally normal. All you have to do is find a way to construct many different beginnings, middle, and ends in a completely non-linear open-world game. One of the first things I would advise doing is thinking about the demands of the game design. Look at what the gameplay mechanics are, look at what types of activities the player can be engaged in. And that's one set of factors that'll apply pressure on your overall solution. And from the other direction, you're going to have the wants of the music design. This is often the whole of the sound team coming to you with all sorts of different ideas about what the music should be doing, notably audio directors and lead sound designers, Dominic. So you end up with game design coming in from one direction, the music design coming in from the other direction, and you're kind of sandwiched in the middle. So once you understand the game design and you understand the music design, you need to find a way to map the two together so that the game design can affect the music design, or you can use chunks of the music design to cover parts of the game design. Now, for me, Rage 2 wasn't completely overwhelming because we'd spent a lot of time on Mad Max iterating over certain principles. So I had a lot of ideas about how this would work in the bank that I could carry over onto Rage 2. One important thing was we'd already established a rough structure of beginning and middle and end for most of our kind of action moments in the game, notably the vehicle combat and the on-ground combat. In Mad Max it's punching, in Rage it's shooting, but it's more or less the same. What worked for us was this loop where we would start in exploration, move into tension, then move into combat, and eventually out into some other kind of resolution. It could be tension again, as we saw in the Schubel example, or possibly even just silence. In Rage, we built the template out a little bit more. We added 2 different types of tension, danger and anticipation. We formalized a combat intro, a combat climax, and we added an aftermath state to give us a more natural resolution to combat that wasn't something more aggressive like tension. We also have, in parallel, certain interrupting actions or modifiers to the moments. There's moments when your health is critical, you're dying. In Rage, you have your overdrive, overpowered mode, and you have the notion of combat performance, which is the combat bad, combat good. In Mad Max, we only really use 2 instances of this template, but in Rage, we expanded that to a whole range of different gameplay activities. And that helped us work out what themes in Elias we would need and the boxes inside of those themes we needed to fill with music.
When we talk about the boxes, Zan, I think this is something that we were talking about in the formulation of the talk, and I wanted to bring up in it, was when you're doing that mapping process, what is the ratio of unique written musical boxes to the scripted states that you were talking about earlier when you're making that mapping from the music's design to the game's design?
That's a great question, Dom. On to Rage 2 implementation. So we understand what the music design is supposed to be. How are we going to implement that into the game? First of all, I carried this idea of vehicle combat and on-ground combat over from Mad Max into Rage, and I started to build out the idea that I wanted to have a state machine for every category of gameplay you could be engaged in Rage. That meant I ended up with multiple versions of a state machine templated out, one for vehicle combat, one for encampment, and one for open world combat. I could also then start to build inheritance into the notion of different activity types. So briefly earlier I showed you the example of the open world encounters inheriting from generic gunfight. Without having to look at our scripting, this is what it looks like. You end up with a base combat state, and then the encampment combat and the open world combat inherit from that and extend and modify the base. And as I explained earlier, activities get resolved by a single gameplay state machine to output a single piece of music at any given one time, or a single Fmod mixer snapshot. And again, in plain text form, it would look something like this. You'd have the encampment combat and vehicle combat, and then they become interleaved over in the gameplay state machine, and they're resolved by the priority of the gameplay state, low to high. Over in our scripting, it ends up looking something like this. The keen-eyed might have noticed that there are actually 2 state machines in that GIF or GIF. Now, they're both part of the puzzle that resolves music, but again, I'm sort of simplifying the scripting on Rage for the sake of making a more cohesive presentation. So that gameplay state machine, when it's triggering states in some kind of order, works as the narrative backbone to tell a story. Here you start with tension as you approach an enemy camp. At some point you get interrupted with vehicle combat, and then you resolve in the aftermath of the vehicle combat scenario. The hierarchy of activities is part of the mapping, but the prize here is the narrative state you get from the gameplay state machine. The gameplay state machine, with all of the transitions and all of the permutations of state summed together, give you a multiplication of the narrative sections, the interrupts, times by all of the activities, which gives you the potential to fill an enormous amount of boxes with specific pieces of music. And often you wouldn't want to commission that many pieces of music. You can reuse a lot of chunks. And simultaneously, you have an enormous amount of mix states available, which are much easier to commission and for someone like Dominic to script up. It is an awful lot of work, but once you've done it, you've got this amazing narrative backbone that you can hang the rest of your sound design off of. And importantly, it's not a back-breaking amount of work because of all of that power that's baked into the nodes that I'm using to script with.
So, what have we learned? Some of the things audio folks need to bear in mind, at least within our experience, is that production designers and game coders will often refer to our context driving as systems. Music systems, mix systems, and it's littered in job descriptions and industry literature all over. And really what we've found, and Zan will always kindly remind me of and drive home, is that it's really only bespoke script.
So kind.
Another one of our really brilliant technical sound designers, Ronnie Mraz, has written on this before, the fact that these are not really systems at all, but more of a paradigm. And in paradigms, we find working models and patterns to use. Some of those are to find principles and standardize them. If you find two similar principles, try and find a way to generalize them. Remind yourself while learning that the problems in these designs will present themselves over and over, so refine your solutions to common problems. And it's just like solving for sound design and programming. And to the coders and sound designers, don't block yourself by being afraid of not knowing music theory or code or sound design. Anyone can learn to think about data, music, and sound.
So I never really had a musical background like a lot of sound designers do. And I started with this kind of work back on Dead Space Extraction, running all the way through to the current titles I work on. I used to consider my place in this work technical sound design, and to an extent I still do. But in recent years, I've seen more and more talk about a new kind of job role in the industry, this idea of music design as a specialization. And I think what I've realized in the last couple of years is that a lot of the work I've been doing is teaching myself how to do the job of music design, alongside a lot of colleagues that are helping with the input, the audio directors I besmirched earlier, and of course all of the composers that I work with on different projects. And it's a lot about all of us coming together to find custom solutions to music design and structural problems. And when it comes to identifying and encapsulating these principles, I think it's really helpful to try and find analogies that you personally can work with, like activities as context. It sounds simple, and hopefully I've made it look really simple in this presentation, but ideas take iteration. It took me quite a long time to formalize that idea of activities as individual state machines. I was working with the principle all the way through Mad Max and into probably the first third of Rage before I finally started to formalize the idea and actually formalizing the scripting structure, having different activities as different state machines. Find what works for your game and for the way you think. So my brain likes to parse these problems, break them down into solvable units, as I suppose most of you do. And I like this way of working with these music problems, the needs of the game design and the wants of the music design, starting from the edges and working inwards. The work we did on Mad Max to come up with a theme template worked well for Rage 2 because the game mechanics were quite simple. There's a lot of car combat and a lot of on-ground combat. Once you have a versatile and broad enough musical theme template, you can start to look at how you can use that template to cover activities rather than how activities might cause you to commission new music.
So from the creative end, it can be important to bake reusability into the music that you order. That early design phase, determining what is the best music categories for the once the game's design, is essential. On behalf of composers and audio leads, earlier in the talk I inquired to Zan about how many one-to-one states and unique musical content was in Rage 2. But clearly it really doesn't matter. In Second Extinction, we found that we could apply many different unique musical pieces to generalized states that expanded as the project grew to great success. This template might not be right for all games, but it worked well for those two projects, and we use a slight variation on that for Second Extinction as well. Once you have a versatile and broad enough theme template, you can start to look at activities in terms of how to use a theme to cover it.
And one other key principle I want to mention that I learned, I think, all the way back to Dead Space Extraction, that has always been incredibly useful, is data isn't king. The narrative is king. In other words, when you're exposing things, use names and not numbers. So gameplay is going to generate a bunch of numbers, and from that you're going to derive a bunch of states. Where do you want to inject control? You could take over the numbers and change what they are in an attempt to gain control, or you could take over the states and change what they are as a way of gaining control. Early on in Rage, the audio director, Tobias Olgård, and the sound designer who was doing a lot of work with the mission music scripting begged me to expose a bunch of parameters so that they could tweak and change and recontextualize music, primarily for different scenarios inside of missions. So I used Arc to generate an Arc control panel where they could tweak a bunch of the same numbers I was using to make logical determinations about when to play combat. The idea being that they would tune it here, tell me what numbers worked for them, and then I would go and implement them in the state machine. And they never really, as far as I can remember, sat down and did that, just because I don't think it was a very useful or an intuitive way for them to go and sculpt and rescript the music. So eventually I came to the realization that the numbers meant it was difficult for sound designers to sculpt this general rule. It was also time-consuming to rescript a bunch of numbers for specific contexts. So usually when people say they want to take control of music, they know what it is that they want the music to do, and they want the music to do that now. So you might as well let them set it directly. I would advise, if you can, let people control what states are active rather than what numbers are affecting those states. The states here are the names you give to things. We don't tend to talk in terms of intensity 0.5. We tend to say, I want combat music here, or this feels like tension, or this feels like aftermath. In other words, the states are the names of the concepts that we want to work with. In Second Extinction, we've exposed the ability for game designers to force and lock the music state machine to whatever they want in a certain context. So there are places in the game where a designer knows that they want to force tension in spite of what they're able to achieve with the spawning scripting. And this gives them the power to do that. When they release control of that, the state machine will default to evaluating to what logical state it would have been in were it not under control of the designer, which is quite a simple state logic override. So I mentioned that a lot of this work is music design, but also not all of it is music design. So what is the other stuff? You have the wants of the music design, and that's the creative pressure that's being applied from the audio side. That's where you make your templates for themes. That is the music design. But on the other side, you have the demands of the game design, and I think that ends up being something in the service of music design, but it itself isn't music design. It's much more general than that. It's a kind of narrative state design. The narrative states you're creating aren't just about music, even if that was the reason you created them in the first place. They're useful to the whole game.
And where we've taken this, when the coders and technical sound designers provide all this deep context via states, has been to honestly super interesting sonic explorations all over our soundtracks. We can match the player's emotional experience, like tracking combat with music, obviously, but matching that to mixing our combat states. So we do things like dropping out unnecessary low-frequency content, removing ambiences to make enemy spatialization even clearer, and all of these things are huge wins for the player experience. Using a player threat level and their whereabouts within a cave and triggering eerie enemy laughter deeper within can draw the player in and tell a certain story sonically. Technically speaking, loading and unloading resources, modulating sound events, or even making characters' dialogue systems more aware to restrict or enable appropriate voice responses are all areas that this can be applied in.
In the future, I think it'd be interesting to expose the narrative background to the rest of the game so that other aspects of the game can use that for storytelling as well. Lighting, it could modulate VFX in the same way as we modulate sound effects, and it could also be used to contextually drive animations. And the final principle that I want to mention today is what I brought up right at the beginning of the talk. The golden rule, I think, is, at least for sound, you want to infer the player knowledge as well as knowing the game design's intention. You want to know what the omniscient game director knows, but you also want to know where the player thinks they are, how they could and should feel about that, and what the player thinks they're doing, the player's story or the story that the game designer is trying to push on the player. It's the player's location and their action. Find data that helps you derive the player's experience. For example, what might they be feeling, what they might be trying to achieve right now. Try not to contradict the player's experience, like in the original foreshadowing example. And usually when sound designers, music designers, whoever, game directors are looking at the game and they're thinking, what feels right here? It's almost always what feels right to the player. In music and sound education, you're often taught that they can be used as tools to help reinforce what's happening on the screen. For us, that's the player's knowledge. You're also taught that it can be used as a tool to allude to something extra, something that's not already in the script, in the storytelling experience, something that's not visually present on the screen. And for us, that's the game's design intention. Neither of those is better to use than the other. The most important thing is use both.
So, in closing, music is probably the stem most in need of our narrative technology in order to function. It's certainly one of the most audible compared to something like how the mix is changing or more subtle elements meant to drive player experience. But it's not the only thing that can be driven by narrative tech. Get into the work early in production while game mechanics and features are being made so people can help you capture the narrative state of a task as an integral part of the work. While Zan and I were working together on Second Extinction, based on his past experience and knowledge, he knew to ask our animation and AI programmer Tobias to let him know when he was working on multiplayer AI targeting, so that he could know which dinosaur was targeting which player, was the local player, and he could parse that to our state system so that I could create custom music experiences for the player. As sound designers working with the composers, often audio is actually ahead of schedule in terms of thinking about narrative and thinking about player experience in terms of a game's production cycle, and Second Extinction was no exception, where we were the first ones to start requesting features for some sort of awareness state for the player long before the production knew that other disciplines were going to need a combat state. Narrative is always king. It's like watching an early cut of a film or even reading the script to do an SFX spotting session. You find the player's story of the gameplay and make sure that you can represent it.
Quite a few Avalanches have presented all sorts of different material at other conferences over the years. Two I'd recommend you to check out are, of course, a talk by Dominic Vega, which I'm not mentioning just to promote Dominic. I think this is an interesting companion talk because it goes through how to approach mixing in a very sort of methodical, state-like fashion. So it uses a lot of the similar principles that we've been talking about in this. And similarly, Ronnie Mraz's talk about dynamic music in Just Cause 4 will give you a look at a thing that we've kind of obfuscated in this talk, which is what happens when you shoot data out into your middleware. So Ronnie goes through the logical scripting he set up inside of Fmod for the Just Cause 4 project, where they were using less of that sort of centralized narrative backbone.
Zan and I really want to thank you for coming out to our talk, and we're going to break for a Q&A after this, but we also want to direct people who want to hear more about what we're making to our emails and especially to our careers page at Avalanche Studios. We're always on the lookout for audio programmers, technical sound designers, and sound designers to join our studio to help us make games, and we would love to hear from you if this kind of topic and this subject material really interested you. We'd like to cut back to the conference for the Q&A session, and Zan and I will be around live to answer your questions. Thank you.
Hi, thanks for a great talk. Yeah, I found it really interesting when you're talking about using states rather than numbers. But I wonder, like, if you have like a kind of more generative music system, then maybe bringing the numbers in could help. Like you were saying, talking about intensity. Maybe if there's some way of like continuously modulating the intensity of a generative music system. Yeah, I'm kind of really intrigued by that. And any thoughts you might have on that?
I'll take it. Oh, sorry.
No, you go first.
I think it's a great idea. I think it's also something that we kind of had to blow past it really quickly. We can do both, which is really nice. So there are a couple cases, like in Second Extinction, the dinosaur game that we were referencing quite a bit, where we may use a named state more globally, and then that state has intensity tied to it. And that's just basically based on request. So it's fairly simple for me to go in and get the actual math number to say, maybe Zan is deriving that 10 raptors equals this narrative state. But I can go in and actually pump out another number that says, I want to know the exact number for another use case. And I want to push that into the music if I'm doing something generative, or what we do is like really sliced up pieces of music that are playing in succession. So it is possible, and it's a good way to work I think what we found over time was that injecting lots of numbers into the system creates a lot of overhead for sort of the audio team, the sound designers who are implementing the music will struggle over time on a large game to ingest all those numbers versus just narrative state.
Yeah, and I think it's kind of, I guess when I was talking about the numbers, it's more the scaling of defining the rule that you want to use to sort of trigger something. So that's where I'm talking about overrides. Whether or not you're sort of pumping music in numbers into the middleware is more about the structure of the music you're using. So if you're doing the kind of classic crossfading between streams, you still use numbers there. That's not really generative. That's just a way of doing kind of music transitions and selections. We don't really, or haven't yet, sort of worked with anything generative in any games in runtime. We're basically just like picking boxes and stitching them together, just kind of what I'm presenting here. Like if you could do this, like the Tomb Raider's AI driven like drum kind of thing, that would be, awesome to have driven. And I assume they're driving it with a bunch of different numbers and things like that.
Great. We've got a couple questions from online.
Yeah.
Minsu says, thanks for the great session. It was so informative and inspiring. Could you please let us know what formula or criteria might be used or considered internally to decide current combat state is combat good, combat bad, or combat climax in your examples from the session?
Yeah, I'm glad I didn't have to type that one out. It is quite complicated. I guess a simple version of it is in quite a lot of games you have a notion of like high intensity combat and low intensity combat, and again it's like a number line, but we're carving it into discrete ranges. In Rage we decided basically everything was always high intensity, so we wanted to try and find a different way to make the music more distinct in different phases, and we came up with the idea of combat good and combat bad. And it's kind of a lot about counting the number of enemies and your interactions with them. So one thing would be like, are the numbers of enemies increasing or decreasing? Increasing would be sort of spawning or more waves coming in. Decreasing is you basically just straight up killing them. And other things like, is your health ticking down? That means your sort of combat performance is not so good. Do you have like a kill streak going on? All sorts of factors. Combat climax is if you've been in combat long, I'm trying to remember this from 2 years ago. If you've been in combat long enough, then we kind of have space to round off combat. If you have sort of quite short bursts of combat, you don't really want to have a big sort of climax ending. But if you've been playing that scenario for 3 minutes, we start to tick down the last couple of enemies and trigger a climax section there. So again, we shift music before it ends and then do the classic kind of play ending stinger transition back to silence or exploration or something like that. That's probably about as much detail as I can pull right now.
Okay, we have time for one more. Thank you for the interesting talk. When you're working on large projects like Rage 2, how do you begin approaching the sound design, especially when these projects are still being defined story and narrative wise early on?
That's for you, Dom.
Yeah, so I didn't work on Rage 2. I've worked on like the Just Cause series. Actually, while the team was working on Rage 2, I was in the studio and the team that was working on Just Cause 4. I'll just steal this because it's a very similar IP in terms of the kind of insanity and the size and the scope. It's really difficult. You're basically kind of trusting, you're kind of leaning on the other departments a lot to figure out what the end goal or the end design vision is for it. As far as narrative is involved from there's a whole narrative team in the company, and they're involved from the moment we start production on a game, and we're all building it together. Like Zan said, I think in Rage, I think you do wind up, the sound team is always relatively first in this regard. It's really, really important when we're talking to composers. We need to produce anywhere from 4 to 8 hours of music for a game of that size. we need to start 3 years from ship to get that much content completed. And when everything is gray box and there's no art and there's no dialogue, it can be really hard to see what the end goal is. I mean, a lot of it is just sort of preparation and planning and having lots of meetings and concepts and talks about what the end goal is going to be. But a lot of it is wasted, or not wasted. A lot of it is thrown out. There are gameplay modes in every game that we've worked on that we've sunk weeks or months into generating a state for that end up not making it into the shipped game. In the talk, he kind of goes over it, but the more broad strokes approach does enable us to not be super tied to the narrative state. So we've found that we don't commission music that is hyper specific unless it's like a main beat of the game, a narrative mission, a finale, a boss fight, these kinds of things where we absolutely know they're going to happen. The rest of it is relatively generalized.
Great. Time for one more quick one. Okay, maybe not. Looks like we're over a little bit over time. Oh, did somebody else have a quick question? I thought I saw a hand go up. Okay.
I'm going to try and go over to the gather space for maybe 15, 20 minutes as well. I think everyone at the conference has a break. So if you're online, you can catch me there. I think you're coming on as well, though.
Yeah, we'll join there as well. Thanks so much for coming. We really appreciate it. Shoot us some emails or some questions if things come up later in time and you're thinking about this. Appreciate it.
Great. Thank you, Zan and Dominic.